All right, Jimmy, when you're ready.
Last year in Paris, California, as a result of a campfire, 86 people were killed, 14,000 homes were destroyed, and 153,000 acres burned, and altogether that created the largest and most destructive fire in California state history. On a larger scale, current trends of fire are leading to increased activity. 500,000 acres burned in 2017, that increased to 800,000 in 2018. And so this was, one link of the increasing activities that of climate change, which was pointed out by Margaret Thatcher in the stimulus packet. In her speech to the United Nations, she said that the result of environmental change in the future is likely to be more fundamental and more widespread than anything we have known. And the link between increasing wildfire as a result of climate change has been proven, and it's said that warming temperatures have increased the fire activity and are projected to increase in frequency and intensity in the future. And the current methods are not working to counteract this change, and as the change worsens and the situation worsens, how will current methods still work? So this led me to my research question of how can the use of artificial intelligence transform the methods for predicting, detecting, and responding to wildfire? And over the course of my research, I found that artificial intelligence is more accurate and more efficient for dealing with wildfire than what has traditionally been used. So it's important to get a definition of AI for how it is used in this presentation. And so it's any device that perceives its environment and takes actions that maximize its chances of successfully achieving its goals. And I focus only on analytical AI, which is cognitive intelligence. The machines learn from their past mistakes to perform future decisions. And this operates only from data directly given to it, I'm not using human-inspired AI or humanized AI, so there's no emotional intelligence, no self-awareness, and that eliminates many of the ethical concerns of the issue. And so the first prong of wildfire is prediction, which must be accurate. And so one company trying to do that is Sylvia Terra. They're a San Francisco-based company working on forest management, and they wanted to get a map of all of U.S. forests with fire prediction. And they get a 15 square meter resolution, which is much better than current prediction models, which have been down to sizes of 1 kilometer. And they use AI algorithms to detect what kind of trees there, and then they calculate the type of risk associated with that. And they can then inform forest managers how to reduce the risk in those areas. And so this is the forest map of Paradise prior to the campfire. And as seen in the east, it's high risk. And then when this is given to a forest manager, whose main job is for keeping the forest healthy and having people safe, they can propose tree clearing, control burdens, or any other fire suppression methods that can develop, and then develop emergency response plans for the event of a fire actually happening. And so the next area is detection, which must be fast and accurate. And it's key because early detection is vital to decreasing the scope and potential loss of life in a fire, and therefore it must be accurate and quick. Existing methods rely on fire spotters, commercial flights, 911 calls, all relying on human observation. And so obviously, not everybody's in the right place at the right time, and therefore some fires go days without being detected. And so additionally, satellites have been used, but right now they're pretty inefficient. It takes 3 hours from the initial data capture from the image being taken from the satellite to transmit it back to a NASA base and then run through a computer there, and then the alert is sent out to people who need it. But AI can lower the processing time to about 3 minutes. And this is proposed by James McKinnon, a computer engineer at NASA. He proposes a neural network for detecting wildfires. And so neural network operates pretty much like the neurons in the brain. It's one given, it learns from what is given to them, and then from there it can learn the associations between the data, and then from there, once new data is given, they can use the associations they have to detect what kind of data it is. So they had a 1 million sample training set, which is satellite images, fire and no fire. And then they learned the classifications that would predict fire, whether that be smoke, flames, or anything else. And then from there, they can correctly classify the new data. And this is very overwhelmingly accurate, 99.96%. And that eliminates much of the false calls, whether that be a fire that's not detected or a fire that's detected but isn't actually there. And so that gives forest managers more time, as the process takes 3 minutes compared to 3 hours as it is now. And they have more time to create or adapt response plans, and then once the alerts are sent to people, they have more time to seek safety. So the third area because all fires can be prevented and not everybody can seek safety in a good amount of time, so response must be quick and efficient to limit the loss of life. And so a group of researchers from Texas Tech University, led by Long Nguyen, they used tweets and a heuristic reinforcement learning model to develop a plan for rescuing victims and coordinating volunteers in the response of natural disaster. In this one, they used response to Hurricane Harvey. And they used a heuristic, which is a way to solve a problem quickly when there's no exact solution. As with natural disasters, with quickly changing variables and situation, there's no exact way to deal with it. And so they take a tweet from a volunteer and a victim, and then they put it on a map, which will then be given to the models that they analyze. So they looked at 6 different models: random response, greedy response, reinforcement learning, and heuristic reinforcement learning. Random is just the volunteers going randomly around, picking whoever is closest to them. And greedy is volunteers picking the closest victim and then moving around that. Reinforcement learning and heuristic reinforcement learning both learn from past mistakes to make a more efficient response in the future. And then they analyzed the results for 4 different results. And so heuristic reinforcement learning perform much better than random walk and greedy, which are the main methods used right now. And so it's the quickest amount of time, the highest reward, and the lowest rescuing cost. And so therefore the AI-based models are more efficient, more accurate, and outperform the traditional models that have been used. And then they can help more victims in a shorter period of time. And so one of the limitations of suppressing fires is the fact that fires are a vital part to forest ecosystems. Limited fires decrease the tree density of forests and deplete the forest fields that may be unused. And when trees are too dense and the forest fields are too much, it leads to a chance of having bigger, greater fires, as seen with the Camp Fire and the high risk of fire. And this, all of these help with not just wildfires, but help with other natural disasters, specifically the one with the social media and analyzing social media to get a response. The same principles apply to floods, tsunamis, earthquakes, as all natural disasters have large amounts of victims in a short period of time who need help and can't reach 911 at this right time. And it also helps forests everywhere, as the monitoring from detection and prediction can detect trees that have been affected by insects or killed. Like seen here, we have the emerald ash borer, which killed a lot of the emerald trees here, or one of the ash trees here. And then out west, bigger problem is the elm bark beetle, which have killed a lot of trees out west. In conclusion, the implementation of AI into current wildfire practices of prediction, response, detection will increase the efficiency of the system. Not only will the scope of the fires decrease, but most importantly, people in higher areas and high-risk areas will be safe as well.
Thanks, Jeremy. Nice job. The first question comes from reflection on the research process. How did you handle the differing perspectives in order to reach a conclusion?
Can you repeat the question, please?
How did you handle the differing perspectives in order to reach a conclusion?
All right, well, to begin with, most people can agree that wildfires, for the most part, are a bad thing and they need to be limited. And so most people can agree that something needs to be done, but then how the steps that need to be taken to decrease that is where the people split up. And so like there's the people that propose AI, like James McKinnon from NASA, and using neural network to do that. And then on the same side, or on the opposite side, there's people that are, there's like, in the Canadian Rockies, one source I read, it focused on fire spotters who, like, for the profession, they live in like fire outposts in the middle of nowhere, and it was their job to walk around detecting wildfire. And so they found that that was effective for them, but then McKinnon found that in the same way, his satellites were just as effective.
Thank you. Okay. And the second question comes from extending argumentation through effective questioning and inquiry. How does your conclusion respond to any of the other research or sources you examined?
Can you repeat the question, please?
How does your conclusion respond to any of the other research or sources you examined?
Okay. My conclusion took the results of 3 different sources. So it took the prediction with Sylvia Terra, it took the one with detection from James McKinnon, and then it took the response of heuristic reinforcement learning. And so it took the solutions of all three of them, and then combined those all into one solution, which gave it a more holistic approach, not just one facet of problem, but like all three of them.
Thank you.